Welcome to EDU AMP. This is an A-level physics lesson all about superposition. And what I want to do today is I want to define what is meant by superposition. And then we're going to draw sketch graphs to show two ways superposing to produce reinforcement and cancellation. Now, you know already a lot about superposition in everyday life. What I mean by that is when you look at waterways, say example here, I've got water and I'm dipping something in and out of the water to make circular wave fronts going out. Well, if I then make different dips in the water like this, as these waves go out from progress out from the source, they're going to interfere. And when we say the waves are interfering, we're going to have superposition of the waves. Okay? And what we need to do is look at the physics behind the superposition as it actually happens. So, getting back to the theory behind this. Well, there's two parts of superposition which is really important, and this is all to do with cancellation and reinforcement. And to show you this, what I'm going to do is here I've got a wave in red and a wave in blue. Now, these two waves are traveling from the left to right. They're progressive waves, therefore they're transferring energy. And what I'm going to do is I'm going to add the two waves together. So what I'm going to do is I'm going to merge them, and the software now is going to merge the red and the blue. Now, because they're in phase, they simply will be on top of each other like that. Okay, therefore the red's behind the blue here, and you can see the blue one. Well, if I show you the two waves superimposed on top of each other, in other words, superposition, can you see now you've got a black wave which is going to be a lot higher. Now, why that happens? Well, let me go back to where I was here. I've got this scenario where I've got the red wave in red and the wave in blue. Now, we're going to say is we take this is going to be the equilibrium position, the distance, the amplitude here, I'm simply going to call it A, which means that distance there also is going to be A. So therefore, when you add these two waves together, you've got a wave going up and down like this. The amplitude comes out with A here. And this wave, I'm going to make it in blue to make it look good, is this wave goes up and down here. And then I'm also going to have an amplitude A. Now, when you superimpose these two waves together, it then makes sense. You then got a new wave coming out, and its amplitude is going to be 2A. And this happens when the two waves are going to be in phase. Okay, and we call this constructive interference. In other words, they're going to interfere constructively, therefore they make a big wave popping out here. And this because two waves are both at amplitude A. And this does happen in the sea, and there's a film, a George Clooney film, all called The Perfect Storm, where you basically get two waves meet each other in phase, make a super wave, and very sadly, occasionally, shipping trawlers do vanish when you get these massive waves coming in, constructive interference. Now, to go back to my simulation, I now want to show you this one over here, going through this one, and hopefully I think it's going to be over here. Now, if you look at these two waves, okay, and it's going to work going through. Now, these two waves coming in. Now, if you look very carefully, these two waves are going to be out of phase. We'll get a right slide coming up. Here it is. Now, looking at this one, can you see now this one is going down minus A, and that's going to be plus A. Now, going back to the work I've shown beforehand, you should now see that these two waves are out of phase, and out of phase by 180 degrees, or it's going to be pi, because this one goes down and this one goes up. So what I can do now is show the waves traveling across, again, left to right from here, is now I can add the two waves together, is I'm going to merge them like this. Now, if I merge the two waves together and freeze it a second, as I mentioned before, this goes up by A and this goes down by A. Doesn't it make sense when I show you the resultant wave, either superposition of these two waves, they're going to superimpose each other, and therefore won't you get a straight line like this? And this is called destructive interference or cancellation. Now, to show you happening is now, as I said before, this kind of wave is going down by amplitude minus A, and that's going up by plus A. Therefore, drawing my waves here, that's going up like this, and this is then going down. So, as I said beforehand, here's going to be the amplitude, that's going to be plus A, and this is going to be minus A. Therefore, now if we draw the resultant wave coming out here, they can simply cancel out because plus A out of minus A equals 0. Okay, and we call this deconstructive interference or cancellation, which is another word for it, which pops out just here. Okay, and you get the waves cancelling out. Now, this is very, very important when we go to other topics, when we look at young slits and also look at stationary waves. Now, so what I've done so far is I've covered these two here. To take it a little bit further, and this is really interesting, is you can then take two waves. Now, these two waves have a different wavelength and a different frequency going up and down. Now, to show you going here, this is really how synthesizers start to work. And also it comes in something you might have heard about called modulation. Now, what I've got again, these two waves going across here. Okay, this wave is going up and down in blue, and this one's going up and down in red, but they have now a completely different wavelength. Now, what I can do now is, well, also, as I've got different amplitude as well, is what I can do is I can merge the two waves together. Now, if I merge the two waves together and freeze here, now you see this can have an amplitude, let's say it's going to be 1, and that could be an amplitude is going to be a half. But when I now show you the superposition of these two waves, it looks like this black line. Now, I think it's better this one if I actually merge them and separate them out. And this is where we get a new waveform coming out. Synthesizers use this by having different frequencies, sound signals going in, or electrical signals, and you can start making any shape you want. And this means a synthesizer can start making music for a violin, a piano, whatever it is, by making different waveforms. So sometimes you can have superposition of these waves where they don't have necessarily the same wavelength or the same amplitude, and then all things start looking quite different. So to summarize what I've been through in this video is I've now taken you through. We now know what superposition is when you're adding two waves together, and you know now when you are superposing the waves, you have a reinforcement and cancellation. Are they constructive and deconstructive? Bye for now.